What do things like power armor from Fallout, exoskeleton from Wolfenstein, these guys from BioShock and Space Marines from Warhammer 40,000 have in common? They are all using an exoskeleton. Yes, they're all using a particular type of exoskeleton, which there's a great variety of, but this particular one is called an exosuit. It's called like that because it encapsulates a wearer, or rather, a pilot, inside of itself, allowing for better protection. It's a perfect human-machine synergy without need of any implants or any complex surgery. It makes a machine basically an extension of your own body, greatly improving things you aim to improve. People use machines for decades, and now when most work is mechanized, the most logical thing to do is to mechanize ourselves. But have you ever wondered, what would it take to create such a suit in reality? Would it even be possible? Well, I did. So I decided to try and build one and see what happens. Technology is power, and the ones that control technology control power. Right now, technology is mostly controlled by mega corporations and governments that fused with those corporations. In the past, a couple of farmers with forks and torches were able to scare the shit out of the elites. Right now, with all these tear gas, water cannons, rubber bullets, the same approach won't cut it. And that's not even including if things become hot, and they'll use actual lethal weapons, which also advanced past the few centuries. It's just a matter of time when that do. The top 1% will do anything to stay in power. We have to develop our own technologies, ones that don't rely on big factories and mega corporations. It is the only way how common people can preserve the democracy and keep the government in check. People simply need new tools to be able to have a saying matter in how government works, to be able to defend their rights. They won't listen to you unless you can block roads and stop production, because otherwise they wouldn't need to, and they would be able to do whatever they want. Okay, now back on the topic. We're going to use some advanced technologies. Joking. Actually, it may be quite the opposite. Most of our exoskeleton is going to be built out of primitive, yet effective, materials such as mild steel. Mild steel is one of the cheapest materials you can get out there. I know some of you may have thought of 3D printing, but 3D printing with even the cheapest plastic is actually much more expensive than using mild steel. Not only that, but most plastics don't even have enough durability that we need, and the ones that do would actually cost even more than using aluminum or in some cases titanium alloys. So we'll stick with mild steel as the most reliable approach in most cases. Mild steel is also good because you can easily weld it with even the cheapest equipment. If you insist on 3D printing, however, you can reinforce your plastic parts with some glass fiber and epoxy resin. It will make them stronger. Not as strong as steel per volume, but that's something. It will probably take much more time, however, and make much more mess. I will be building main frame out of 40 by 4mm steel strip, on top of which I will be welding steel sheets. I would advise to use a range of thickness for sheets in about from 0.7 to 1.5 millimeters. Keep in mind that steel is a very heavy and dense material. Now to the geometry. I weld everything in squares just because it's easier and faster this way. Also because I don't have the right equipment to bend steel strips. I tested bending it by using a hammer, but this process requires too much time and effort, so I decided to not use it for the most part. However, if you have the right equipment, you can definitely make round shapes. It will be better. One mistake I made during building is that I used some K-fel bearings on some of the parts. Don't use them. They're not good for the task. What you should do instead is buy some regular bearing and a pipe with inner diameter as close as possible to outer diameter of the bearing. You will then weld this pipe to a place where your joint is going to be and use a press or a hammer to place bearing inside of it. Be careful not to break it though, and mind tolerances. Your pipe won't fit tolerances perfectly probably, so you would have to use a file or some other tool of your choice. To assemble the joint, I insert bolt inside of a bearing and secure it with a nut on the other end. The smallest bolts for this I use are 8 millimeters, but those end doubled on each side and also made of hardened steel. I hope you still remember that we are actually making an active exoskeleton, because any exosuit would be too heavy to move on your own, so we need actuators. So this will be topic for the next episode.